In a geometric sequence, each entry except the first one is determined by multiplying the preceding entry by a fixed number called the common ratio. So before we had a common difference, now we have a common ratio. Like the arithmetic sequence, the first term of a geometric sequence is called A. An example of a geometric sequence is this. What is R? Well, let's just check. We go any term divided by the previous term. So 1/2 divided by 1 over 8 equals 1/2 times 8 over 1 equals 4. Oh. Let's try the next one. 2 divided by 1/2 equals 2 times 2 over 1 equals 4. 8 divided by 2, oh look at, there's our common ratio. 32 divided by 8 equals 4. 128 divided by 32, and I believe that's 4. So our common ratio is 4. Fair enough? Here's the formula for a geometric sequence, because any term is obtained by multiplying the previous term by r, where a is the first term, n is the number of the term, and r is the common ratio. Let's verify that each of the following are the start of a geometric sequence. Well, let's check. You have to check them all. -10 divided by 5 equals -2. 20 divided by -10 equals -2. -40 divided by 20 equals -2. So r equals -2. These terms are the start of a geometric sequence. Geometric sequence. Let's try the next one. 4 divided by 8 is 1/2. Okay. 2 divided by 4 is 1/2. 1 divided by 2 is 1/2. 1/2 divided by 1 is 1/2. 1/4 divided by 1/2 is equal to 1/4 times 2 over 1 equals 1/2. Okay, this one is 2. R is equal to 1/2. Also a geometric sequence. For 5, -10, 20, -40, 80, find A, R, and Tn. Okay, let's check. We know A equals 5. R equals -10 divided by 5. So R equals -2. And we can check. 20 divided by -10 is -2. -40 divided by 20 is -2. 80 divided by -40. Find Tn. So we use the formula. Tn equals 5, -2 to the n minus 1. That's our general term. For 4, -12, 36, -108, find T9 and Tn. Okay, well, let's just check. A equals 4, R equals -12 over 4 equals -3. 36 over 12 is negative 3. Let's see, is negative 1 over 36 negative 3? Negative 108, negative 108 divided by 36. That equals negative. Just checking, make sure we have a common ratio throughout the sequence. If we don't, then it's not a geometric sequence. Yeah. Ask me after I've looked at the entire test. I don't think so. Because we're out to make it pretty straightforward, give you a break. So, all right, Tn equals AR to the n minus 1. So Tn equals 4 negative 3 to the n minus 1. So there's our general term. And now we're ready to find T9. Yeah, plug in 9 for n. T9 equals 4 negative 3 to the 9 minus 1. And that equals 2, 6, 2, 4, 4. So it's negative 3 to the exponent 8, which makes it positive. So always remember, Tn can stand for the general term, or the last term, depending on the question and what it's asking. Determine the number of terms in the following sequence. Oh boy. Well, 2 divided, let's make sure it's geometric. 2 over 2/3 is equal to 2 times 3 over 2 equals 3. That's R equals 3. 6 divided by 2 is 3. 18 divided by 6 is 3. So we know R is equal to 3. A is equal to 2 over 3. So we know first we find the general term. And that's Tn equals 2/3 times 3 to the n minus 1. And now we're going to sub in this value. For Tn. So we have 393, you signed in? 39366 equals 2/3 times 3 to the n minus 1. Yeah, I'm sorry. We multiply both sides by 3 and we get 118098 equals 2 times 3 to the n minus 1. Then we divide by 2, so we get 59049 equals 3 to the n minus 1. So we can get a common base here. 3 to what exponent equals 3 to what exponent equals 59049. Just try different values. Let's just see. 3 to the exponent 8 is equal to, is it 10? So n minus 1 equals 10, n equals 11. There are 11 terms. Example 5. Then we'll be all caught up. Find the first four terms of the geometric sequence given T7 equals 96, T13 equals 6144. Okay. Equation 1. Using this form, Tn equals AR to the n minus 1. So I'm going to start with the bigger number. 6144 is equal to AR to the 13 minus 1 is 12. Agreed? 2. 96 equals AR to the 7 minus 1 is 6. Now, because we're multiplying here, we're going to go 1 divided by 2. Okay, so 6144 divided by 96, 6144 divided by 96 is equal to 64. A divided by A is 1. This is R to the 6. To solve for R, we take the 6th root. So R equals 64 to the 6th, and R equals 64 to the exponent open bracket 1 divided by 6 close bracket is 2. Now we're going to sub into 1. Now let's sub into 2. The numbers are smaller. To solve for A, 96 equals A times 2 to the 6. 96 equals A times what, 64? 2 to the exponent 6 equals 64. A equals 96 divided by 64, and I believe that equals 3/2. Now we're ready to find the first four terms. You know Tn equals 3/2. So we already know we know T1 equals A, and that equals 3/2. T2 equals 3/2 times 2 is 3, right? T3 equals times 3/2 is no, what's R? R is 2. 3 times 2 is 6, and T4 equals 12. You know what? Do you see an issue here? Do you see an issue here? Could a R be negative 2? Yeah. R is equal to plus or minus 2. So if R equals minus 2, then we're going to have something a little bit different. This is if R equals positive 2. If R equals minus 2, then we're going to have T1 equals A, which is 3/2. T2 is what? Negative 3. T3 equals negative 2 times negative 3 is 6. T4 equals 6 times negative 2, negative 12. So we have two answers. want you to be aware of that, okay? So let's summarize them. If r equals 2, we're going to have 3 halves, 3, 6, 12. If r equals negative 2, we're going to have 3 halves, negative 3, 6, negative 12. Can I explain anything else? So I'll post these.